today we'll continue with the memory acquisition on forensic systems, and we've covered the dump from within during the last week on last Thursday, and I will now start with a few more topics like dumping virtual memory from a virtual machine. So for this session, we'll assume that one or more guests are compromised, but not the host that is hosting the guest machines. So for the memory dumps of compromised hosts, see how it's done in part 1 when you dump machines either through the hardware or through the from within through tools like Memdump. And analyzing a VM host is a bit of another story, but we'll cover that later. So the great pro of a dump of a virtual machine is that we can suspend the virtual machine while dumping the memory so that the state doesn't change during the dump. This isn't the case if you do a live dump, unless it's a kernel crash dump. And as such, as we're doing this from the outside, the rootkit on the compromised host has practically no chance to interfere or notice what we are doing. We still need profiles and symbol tables later of the guest for the analysis, but I've covered that in the first session, so I'm not going into this here. So the first one I'd like to show you is Vmware and how to do this. It's mostly done through a tool called VMS2Core, and I can show you that tool in operation here. Let me just stop the sharing and go to another window. So here we have it. Let's assume this here on the console. And VMS2Core uses two files, the virtual machine snapshot, and which is practically a copy on write of the virtual machine's memory, and the image of the virtual machine's memory itself, which is here. So, and if we try to do this, I can show you that. You can see it has a bunch of options, and the ones that you typically see in the literature is using -m, core dump with physical memory, but I must admit that doesn't work, at least not on my machines with any versions of VMS2Core I've used. So I will use -n, which works quite similarly. It also can dump Solaris or Windows or Mac OS kernels. So the operation itself is quite easy. VMS2Core -n here. It takes a snapshot file, we take the virtual memory file, and it starts to dump. Gets a bit slower after that, but that dump can actually be written to file. Well, gets slow here. Okay, here it is. And we can analyze the core file with the object dump tool. And when we see it here, these sections named load 1, load 2 will contain the contents that we are really interested in. So this core file can be analyzed either with crash debuggers or with tools like volatility. So that's practically all that there is to dumping a virtual machine's memory. We can copy this then away and do our checksums on it or sign it cryptographically on the host. That's all we need to do here for dumping that machine. So, and let me switch back to the slides. Sorry, here it is. So, and that's all we need to do here. So, yeah, I've shown you that. On VirtualBox, the whole thing works quite similar. In that case, we need the debug VM command from vbox manage to dump the core. And we can later see the object session with the same tool. Object dump is a part of the GNU bin utils, should be present on all your other Linux machines. So I'm mostly assuming Linux hosts here. And what we need to take into account is the size and the offset when we extract this from the virtual memory image. This can be done a bit more convoluted with the head and tail to strip off the part before the offset and the rest, or we can use DD and use a skip and then a size count with a block size of 1. And that is equal to a raw image, and that can be analyzed with forensic tools. I see here in the chat that the VM only had 4 GB here, so I had to keep this a bit down so that the dump doesn't take too long. Of course, when your host's file system doesn't support files larger than 2 or 4 GB, you have to do this with some sort of splitting tool. So on KVM, you do this with the virtual host shell dump command, which is again quite similar. And you again have a core file, which can be used like a normal crash dump. And we always can extract the memory and use that as a raw dump. Hyper-V also has a newer feature for that is called checkpoints. They also have a feature called snapshots, but the recommended part from Microsoft to do virtual memory dumps is to use the checkpointing feature. And I haven't yet figured out what to do from here on with the virtual Hyper-V memory checkpoints. So there will be some processing steps you need to analyze this further, but I haven't come around this and I haven't had much opportunity yet to analyze Hyper-V dumps. So I think that's all for now about dumping memory from virtual machine hosts. Now let's go into 2 more topics in the case of memory analysis. One of them is a swap space and hibernation files, and another one will be dumping single process memories. So just as a very short recap, what swap space is: when space in RAM in main memory becomes filled up, the operating system needs to make room there for applications to run. And this means pages will be paged out, or sometimes it's called swapped out, to the backing storage. And when the process is running, they will be paged again into the main memory back to RAM. Swap space itself can be a disk partition. This is the case on most Unix suite operating systems. Linux and Solaris have a partition type 82 for that. BSI uses type B8. I don't know if there are any operating systems around that still use BSD International. Or we have a swap file on Windows. This is usually in the system root. This is in 99% of your cases, system root is just the C drive in the base directory. And these two files are called pagefile.this and swapfile.this. It's actually 2-page files. The swapfile.this is a newer one which came along with Windows 8. So let's start with Linux swap. The swap partition can be imaged with typically for forensic imaging tools, which means we can just copy them off with DD. And Toby will cover this in January in the next webinar. And if you have swap files on Linux, you can copy them just like any other normal file, even when the operating system is running. Of course, state may not be entirely consistent then, because during the dump, the operating system continues working and will be paging. So in both cases, this is probably best done post-mortem. And as you've seen from the previous picture, the swap file will not contain a full copy of the memory, but we can still search for forensic artifacts in these swap files. For example, things like URLs or passwords or disk encryption keys and or malware signatures. And so our typical tools of the trade will be the #1 forensic analysis tool called strings, which we could cover in a bit more detail in a very, very short session. And then there is a general pattern matcher sort of, basically like an antivirus scanner, which you can feed your own patterns. It is called Yara. And if you prefer something more comfortable, you might use a hex editor. But be careful, not all hex editors can deal very well with the files being several gigabytes large. So when a hex editor tries to load all the file into memory, you may hit a very steep, strong performance impact here. But there are hex editors which keep on in memory only a very small part of the file and have the rest on disk. And for Linux, there's also a nice little swap analysis shell script. This is called swapdigger. And let me give you a short demonstration of that. Go back to our console. And then we swapdigger, which is kind of a small tool. Let's make this window a bit larger. We can search for application data. We can choose a log file. We can give it some more parts. I will just give you a small demonstration here with the VA tool. We search for app data. So let's scroll a bit back here. Here we start to call this. Okay, I've done this a couple of times before, so we already have a swap dump, or basically a strings called on the swap partition on my machine. And we have a string file about 20 megabytes in size. And then we can use for stuff like this, various methods to try to get passwords from web formats. We can look for XML data. We can look for Wi-Fi passwords. We can look for HTTP and HTTPS URLs, which are of limited use, but at least we can see that there is something going on here. And a lot of other things, FTP URLs, onion files, local files I had, and like SMB shares or IP addresses. So it seems like I'm most often communicating with local hosts. And of course, I can use this to mine hashes. It can also be used to mine clear text passwords in the swap space. And I've done this, and yes, it actually got to my password. So I'm not showing you this here. But be assured, yes, it does work. So that's all for Swap Digger. Let's go back to the other tools we have. Stop. Here is it. So the Windows swap files are, as I've named, two swap files. Swapfile.sys is only used for universal Windows platform apps. This is the stuff that has been introduced with Windows 8. And on disk, these are mostly the things that you install from the Microsoft App Store and that have these cryptic suffixes appended to them. And in this case, apps will be completely swapped out to this file and not the pagefile.sys. Both files are hidden, protected operating system files, so we need to enable viewing them in the Windows Explorer. And like Linux swap files, they don't contain full memory copies. And of course, if we want to use these files, we need that paging has to be enabled, which is the case by default on Windows. And we have to look at this, that the page file is not zeroed out on shutdown. This is controlled by a registry key, which I've shown here. If it has a value of 1, it means that the page file is zeroed out. And if it has a value of 0 or the key is not present, then the page file will be not zeroed out on shutdown. This is, of course, nice if we want to prevent forensic analysis or even some sort of evil-made attacks on our system. But remember that this comes as a bit of an impact, because on shutdown, it will take a bit of time to zero out that page file. So for the case of collection, these files are locked by the Windows operating system, so we cannot access them from user space, at least not while the system is running. So to copy them, we have to do this post-mortem. We have to boot into a live CD or a live USB stick, or we can unscrew the physical disk from the system and mount it on another system, or extract the files from a forensic disk image. And again, we can analyze these files with strings, Yara, or the hex editor. And of course, if we use a forensic disk image, we have to get hold on the disk encryption key to do this, because being part of the file system, they will be protected by full disk encryption schemes like BitLocker. So that's all about the Windows swap file. Let me continue with the Hibernation file. Hibernation is just what we on Linux call suspend to disk, and sleep is correspondingly suspend to RAM. So the location is the same in the system root, the hiberfile.sys file. But this can be configured in your operating system settings, so you can put the hiberfile sys on another partition, although Microsoft recommends not doing so, especially in the case of BitLocker on many partitions if it's not on the same partition as your operating system, you might have problems accessing this, and waking up from hibernation then wouldn't work. The Hibernation file does contain a full copy of the memory, but it is compressed. It's called with an algorithm called Express, which is a modified LZ77 algorithm. Microsoft has documented this algorithm, also a bit faulty documentation, but it has been successfully reverse engineered. And so we can try to analyze it with standard tools. I come to this. And yeah, it contains the kernel session, the device drivers, and the application data. So, and if we want to activate Hibernation, we can use the power config tool -hibernate on, or to deactivate it /off. And on the command line, we can use the shutdown /h command to hibernate. This is a bit different from the shutdown -h on Linux, which will actually power off this system. Again, collecting is through means of forensic disk imaging, and the processing can be done with the two tools. One of them is volatility, which can use where we can use the image copy command and then convert the hiberfile.sys into a raw image. However, we need to use the correct volatility profile for this. Another way to do this is a tool called Hibernate, which is a continuation of the Sandman project. I think the guy behind it is Matthew Sush. I'm not sure if I pronounce his surname correctly. And he is actually better known as the guy by the nickname of Scudet, which had branched a volatility fork into something called Recall. And Hibernate has now landed at a forensic firm called Kelm, and they have released the source on GitHub. Unfortunately, it's a Windows-only tool, so you have to compile that on Windows. But you can use it to actually convert a hiberfile.sys into a raw image. So that's all I have to say about virtual files and swap files. And let me continue with the case of single process memory dumps. Why should we do this if we can have a full forensic image? Because sometimes this may be a bit too much. We only want to have a peek into one or very few processes and don't need to investigate the whole systems. Or we're lacking privileges to dump the whole system, so we're just ordinary users, or we are not allowed to do that because the system may contain private or confidential data that we shouldn't have to look at. So in the most naive way, we can do this on Linux with the just trying to copy off proc process ID mem, and this won't work. We run into a error. So let me show you this live. Switch to another window here. So let's see if we have a bash system here running. So we can go to proc 2660 and have a look at the mem file, which just looks empty. So if we do we run into an IO error. And this is because, of course, the system, the process is not completely mapped into memory. And when we try this, we will hit a non-mapped page just right at the first page when we try to copy from address 0. And so our copying process stops here. What we need is another map. This is called the process map. is in the same directory. And as you can see here, we can see all the pages that are, or segments that are mapped into memory, mostly the files we need, all the locales, but you can see here something like the stack. And further up here is the heap. And we can use that to copy off all the scripts we have. One of them is a Python tool called Memdump. I think I have this on my machine. Memdump Py. Does it help? Yeah. Huh? Yeah, I just need the. Huh? Ah. Quatsch. Memdump. So. And there we have our. Seems that I didn't have the right paths en route. So another way to do this is a very nice tool, which is the ProcDump tool, which is available from sysinternals, both on Linux as on and on Windows. And you can use ProcDump to do the memory dumping. And then we again have there it is. So it's not a big file. It's just a very small file. Another tool is delivered with the GNU debugger, which is called GDB, G-Core. GDB is the GNU debugger. And not -b. And again, we can have this here as a core file. So, and from here on, we can use just typical debuggers to debug the process, or just have a dump of the systems file by itself. We could also have just a peek into the part of the memory. So for example, we just want to have a look at the heap of our bash. We can use that and try to use this. So we have here our memory section that we want to have a look at, and we can use this to skip a bit from the start. So when you do this on in the shell, you need to do a lot of no, sorry, not count, -L. Is that right? Yeah. Of course. Silly me. And then we can analyze our heap dump with strings. For example, I just want to have a look at anything that may look like a command. So, okay, I've seen this here. I've forgotten to convert that back to binary. Sorry. So, could be done with XXD. Yeah. Huh? Okay, so got myself tangled up. Sorry for that. So let me just continue with our stuff here. So, okay, we've seen this, how we to do this. We could also use a kill to just do a core dump, but that depends on your configuration of your Unix system. If userland core dumps are actually enabled, so this is a bit convoluted. So gcore, proc dump, memdump, etc. will work a bit better. So here it's a couple of things here. So another tool I'd like to show you for Windows is called the Process Explorer and the Proc dump. Again, let's do this on live demo. I'm a bit switching back and forth here. I hope this can be seen nicely. Come on here. So we want to dump a file here. I've seen this here. Process Explorer comes from sysinternals, and you can install the sysinternal suite now from the Microsoft App Store, but you can also download the sysinternal suite as a big zip file and put it on your USB stick and run the tools from there. So when we open this in the File Explorer, let me show you where.
Klaus?
Yeah.
We don't see the tool yet. We still see the slides.
Oh, wait a moment. I'm on the wrong window. Is it better?
No, still presentation.
Hey, I can't show you Vmware. Oh, wait a moment. So then we try to use this with the desktop.
This is better.
Okay.
Thank you.
Okay, let's see if we can go full screen here. Okay, so this should show you now a Windows desktop, and open in program files. Don't know where they did install that here when we installed this from the part, but anyway, we don't need this. We could just hey, come on. So we have the sysinternal suite here, and you can see them. It's quite a lot of tools. And one thing is the Process Explorer, which I've shown you here. And this is a very nice tool, which has a ton of features. And yeah, if we want to dump a process, it's very easy. We just click on the process, right click on it, scroll down to create dump, usually best done. Of course, if I'm not debugging my own processes, I should do this as admin. Maybe it's back. So again, and I should now be able to create a full disk dump like SQL writer -dump, and there we are. Another nice tool for this is the Vmware tool here, which gives you a very nice overview of the pages and sections that are mapped into memory, but Process Explorer can do this also. So, and there's also the command line tool, which just got away. Let me use this one here. Yes, I want to do this. So, and again, Proc dump on Windows has a lot of more features. So what we here have to take care of is that we use the -MA switch to write a full dump if we want to later analyze this. And Proc dump has also the nice way of that you can define a lot of conditions on when to dump a process. And as you can see here, it's quite easy to use. And there we have our dumps, which are not entirely in the same size, but I admit that there are small differences, but the process itself might also have been changed a bit in the 2 moments between the time I took the dumps. So that's one of the things we own. One of the other features for that is nice for Proc dump is that you can take several dumps, several seconds apart. You can automate that process with Proc dump, so you can have, for example, when you have memory leaks in a process, the way of seeing how the memory grows into different parts of the system. Thank you for your attention and all the time you have spent with me and my colleagues, and wish you a Merry Christmas and a nice and happy and healthy 2022.